Here is all of the explanation to using absolute value when we're talking about inequalities and equations. The trick that Miss Hurley told me today, the less than, when we say the words less than, the than is the only thing that sounds like one of our rules. This is going to be an and situation. When I use the greater than, greater sounds like or. So I take the less than, reminds me of and, greater than, I have an or in there. I still have the than, but I also have the greater. So when it's a greater than symbol, it's an or situation. That's what this up here is explaining to us when we use and when we use or. Let's go back to our ones I just solved. This was a greater, so it was an or situation. This was a less than, so that is a and situation. Okay? So let's go ahead and see if we can work one of these out. This is just simply a less than situation. So it's not an equality, it's only an inequality. So when I'm going to solve this, I'm going to say again the quantity x minus 4 could end up that it's positive. So I'm going to say, because of absolute value, that quantity could be positive. I'm also going to say that it could end up negative. X minus 4 could be negative. And because I'm saying it's a negative, I'm actually multiplying by a negative, which means in inequalities, I need to reverse my sign. Okay? It's a less than, so that means we're going to use and as our compound inequality. It won't be an or. That goes back to the beginning of this chapter. Same thing in solving. Get our like terms together, adding 4 to both sides. And that's going to be true over here as well. So that is the same step. However, our quantity is going to be different. This one's going to be that x is less than 7. It's a less than, so we have an and, cheating a little bit there. And x, we reverse this because we changed it to a negative, which means we multiplied that answer by a -1. That in inequalities means we reverse the sign. -3 combined with a +4 gives us a +1. All right. I want to write this because it's a compound and it's an and. I can write this as one statement. The x was greater than 1, but the x was less than 7. Again, that's from writing it as a compound is from the beginning of the chapter. So this time we have a two-step equation that also has to do with an inequality and has absolute value in it. So again, it's the quantity. This goes with example 2 from this lesson. So I can have it that it's a positive answer or a negative answer. First though, I want to get my like terms together. So we're going to go ahead and say the 2x plus 1 is a quantity now. I took away the absolute value, those are supposed to be parentheses, minus 3. And that's going to be greater than, or equal to 6. And the next one, I'm going to say the quantity 2x plus 1. 2x plus 1, quantity again, minus 3 is going to be greater than or equal to 6. So my first step was just getting rid of the absolute value signs. The next step is the same on both of these. Get our like terms together. Like terms together. But because we are dealing with absolute value, we can have that quantity that was in the absolute value bars is going to be greater than or equal to, and this first one would be a positive 9. The other side would be that the quantity 2x plus 1 that was an absolute value is greater than or equal to a negative 9. Now, because I did a negative, I need to make sure I multiply by a negative, it's an inequality, that I reverse the sign. I made it that it could be a positive answer, and I made it because it could be a negative answer. To do a negative, I multiplied by a negative 1, so because it's an inequality, I needed to reverse the sign. So now I go ahead and I solve it. It's a simple sentence now. So I could have, when it was positive, it's 2x greater than or equal to 8. Divide by 2, divide by 2, x is greater than or equal to 4. This side, same process. Negative 1 combined on both sides to get like terms together. Still end up with 2x. Remember, my symbol got reversed because I was dealing with multiplying by a negative to get this negative 9. A negative 9 minus 1, or combined with a negative 1, gives me a negative 10 on this side. Divide both sides by 2. I want to solve for a single variable. X is less than or equal to negative 5. Now, if I apply my Miss Hurley trick, this is a greater or equal to. So it means my equation is going to be an or. I'm going to bring my graph up. I'm going to just cover kind of our process here to show you our graph. Oh, I guess it nicely fits behind there. Maybe I can fit it over here. So because it's an or, we're going to have the directions shaded going in 2 different ways. Let's change this to a yellow. So my first answer was that x was greater than or equal to 4. That's this shading over here. Okay. And we'll make this one green. This one says x is less than or equal to. Again, it's an or, so this one's going to go the opposite way. It's a solid dot and shaded to the left because it's less than. I don't know if we can get this all done in one day, but I'm going to try it, and it's going to be a pretty long recording, so hopefully we can get this posted. The last example is going to talk about, again, a real-life situation. You work in the quality control department of a manufacturing company. The diameter of a drill bit must be between 6.2 and, I'm sorry, 0.62 and 0.63. We have an and in here. So if I was going to write that equation, I would write that inequality, so write an absolute value inequality represent this requirement. So I'm going to go ahead and I'm going to put that 0, oh my goodness, that my variable that I don't know what it's going to be yet is going to be greater than or equal to 0.62, but it's going to need to be, because it has to fall in between these, 0.63 is greater than or equal to. So let's say that our diameter, so we'll use the variable d. All right, so this information is letter A, and letter A, I got that from right here. Now, letter B says the bit has a diameter of 6.23 inches. Does that meet the requirement? So if I look at that requirement, I can say, does that on a number line fall in between there? It would be greater than 0.62, but it still would be less than 0.63 on a number line. We could see that. So if I had a number line, and I put these points on it, so they're both positive, so I'm going to put my 0 here. So then I would have my 1 would be way up here. Neither one of these are complete 1 inch. Halfway point would be 0.5. I'm going to put my, let's see, 0.6, 0.7, 8, 9, and 10 would give me a full 1 inch. So here's my 0.6. Let's go ahead and 0.62 then would be right about here. And, let's go back to black. 0.63 would be in here. So my diameter of 0.623, what haven't I used yet? Would end up, this should be interesting, falling right in between there. You can change it to money, but we don't have hundredths, or I'm sorry, we don't have thousandths in money. But if I was going to write these, I would start adding digits onto here till this would change to 30, which is the 0.63. And that is the end of lesson 6.4.